Happy morning, student. Next semiconductor device is photodiode. In a previous video, we have learned the first semiconductor device, rectifier, PN junction diode as a rectifier. Now, let us see photodiode. What do you mean by photodiode? A photodiode is a special type of PN junction diode which convert light energy into electrical energy. It generates current when exposed to light. It is also called as photodetector or photosensor. It operates in reverse bias mode. This is the property of photodiode. Photodiode is operate in reverse bias mode. Then symbol of photodiode is shown in this figure. This is the symbol of diode. This is the first terminal anode and this is the cathode. And this arrow indicates that it is exposed to light. Then structure of photodiode. This figure shows the constructive diagram of photodiode. The PN junction of a photodiode is placed inside a glass material so that only the junction of a photodiode is exposed to light. Other part of diode is generally painted with an opaque color or covered. When a PN junction diode is reverse bias, a reverse saturation current flows through the junction. Because photodiode is operated in reverse bias, the magnitude of this current is constant for a certain range of reverse bias voltage. This current is due to minority carriers on its either side. The reverse current depends only on the concentration of the minority carriers and not on the applied voltage. This current is called the dark current in a photodiode because it flows even when the photodiode is not illuminated. One important concept is here. This is the dark current. Okay. Then it consists of the P region, N region. This is the silicon nitrate coating. This is the mask of SiO2. And photodiode is always connected in reverse bias mode. Then working of photodiode. This is the photodiode. This is of course the PN junction. Light is exposed to it. This is P-type semiconductor. This is N-type semiconductor. When the P-type semiconductor is connected to the negative terminal of battery and when the N-type semiconductor is connected to the positive terminal of battery, then that bias is called as a reverse bias. And photodiode is always connected in reverse bias. When a PN junction is illuminated, a electron-hole pair are generated in the depletion region. The energy of incident photon should be larger than the band gap of the semiconductor material used to fabricate the photodiode. The electrons and the holes are separated due to the electric field present in the depletion region. Electron hole pairs are first created and then electron and the holes are separated due to the electric field present in the depletion region. The electrons are attracted towards the anode because anode has a positive potential and the holes are attracted towards the cathode because cathode has a negative potential. More carriers are available for conduction and reverse current is increased. because photodiode is connected in reverse bias. Therefore, here the reverse current is increased. The reverse current of a photodiode depends on the intensity of incident light. It is very important point. The reverse current of a photodiode depends on the intensity of incident light because light is exposed on it. Thus, the reverse current can be controlled by controlling the concentration of the minority carriers in the junction. Then IV characteristic of a photodiode. On x-axis there is a reverse bias voltage, okay, and on y-axis there is a reverse current. And one more thing is here, the dark current. The total current passing through a photodiode is sum of the photocurrent and the dark current. The nature of graph is like this. Then graphical relation between the reverse current of a photodiode and the intensity of illumination incident on the photodiode. See this is the graphical representation of reverse current of a photodiode and intensity of incident light. On x-axis there is a value of intensity and on y-axis there is a value of reverse current. Okay, then the sensitivity of device can be increased by minimizing the dark current. As you can see from the curve, reverse current increases initially with increase in the intensity of the illumination. As the intensity of the light increases, the reverse current increases. Then it reaches a constant value. Say this, there is a constant value. After certain voltage is reached, and this constant value is called as a saturation current of a photodiode. First, the current increases as the intensity increases, then it reaches a maximum value and then it becomes constant, and that constant value of current is called as the saturation current of the photodiode. Next point is dark resistance related to the photodiode. It is represented by the letter RD. R for resistance and D for dark. It is the resistance of a photodiode when it is not illuminated. Dark resistance of a photodiode is defined as the ratio of the maximum reverse voltage and its dark current. Okay, you know that according to the Ohm's law, R is equal to the V upon I, and this is the definition of dark resistance because in the case of photodiode there is a dark current and therefore dark resistance is defined as maximum reverse voltage to the dark current. This ratio is called as a dark resistance. Then next point is advantages of photodiode. First advantages, quick response when exposed to light, means it is the spontaneous process. Then second, linear response. The reverse current is proportional to the intensity of incident light. Just we have seen the graphical representation of reverse current and the intensity of incident light. It is just nearly equal to the linear graph, that is the reverse current is directly proportional to the intensity of incident light. This is the second advantages. Third, high speed of operation. Its operation speed is very high. Next is lightweight and compact size. It is very portable and therefore it can be replaced anywhere. Okay, it can be transferred anywhere. Next is wide spectral response. For example, photodiodes made from silicon respond to radiation of wavelength from 190 nanometer in the case of ultraviolet to 1100 nanometer in the case of infrared rays. And last advantages is its cost is very low. Next is it has some disadvantages also. Therefore, disadvantages of photodiode. Its properties are temperature dependent, similar to many other semiconductor devices. These property are the temperature dependent and it is similar to the other semiconductor device. This is the one of the disadvantages. And second one is low reverse current for low illumination levels. Value of reverse current is low because for low illumination levels. And of course, last point is application of photodiode. First application, it is used in counter and switches. Useful application is, you know this very well, what is the use of switch, what is the use of counters. Okay. Then next is bulgal alarm system. Bulgal alarm system is used to secure our valuable things in our home. Okay, therefore you can use this bulgal alarm in your home. Then next, detection of visible and invisible radiations. Third, circuit in which fast switching and high speed operation are required. When there is a necessity of high speed operation, then photodiode is used. Then next one is fiber optic communication system, which is already studied in 11th science. What is the optical fiber? What is the fiber optic communication system? Therefore, photodiode is used in this also. Then next one, optocouplers used to provide an electric isolation between two electronic circuit. These optocouplers we have to study in next standard. Okay, therefore at this stage only remember the name of optocouplers. Okay, then next is photosensor, you know this very well. Then next one is detectors for accurate measurement of light intensity. If you have to measure the accurate reading of light intensity, we have to use the photo detector or photo sensor. And next is safety electronics like fire and smoke detectors. It is a device, smoke detectors is a device that senses a smoke typically as an indicator of a fire. Okay. Therefore, it is very important semiconductor device, photodiode, which is used for safety electronics, in fiber optic communication, in digital system, in bulgal alarm system. Okay. Therefore, there are the various application of a photodiode. Let us stop here. Thank you.